Good morning. Today we are going to be reviewing some things that we are not getting to today or this year in pre-algebra. So we're going to look at some stuff that was in Math 6 that because we skipped over Math 6, some of Math 6 we go deeper into in pre-algebra so we're not missing it. Some of Math 6 we just don't cover because we're covering more pre-algebra stuff. So I thought I would take a little time to go over a little bit of it. Some of it is a little review from 5th grade, and we might get to it at the end of the year, but I'm going to refresh our memories now about triangles and angles. And then some of it is we're going to see if we have time today to look at some graphing stuff that we are not getting to. That's new stuff. This is all information that's good to know for when we do the math testing in the spring. It's good for us to know because we're not focusing hard on it in class and it'll come back in future years. So we want to have a little bit of an understanding of it. So first, let's see how much we know about angles. Anybody know any angle names? Robbie? Obtuse. What is an obtuse angle? An obtuse angle is greater than 90 degrees. So it's going to look big. So that angle measurement looks big. Eleanor?
Right angle.
What is the measurement of a right angle?
Exactly.
Exactly 90 degrees. So it goes straight up and straight across. What do we sometimes see in an angle that lets us know it's 90 degrees without being written as 90 degrees? Heather? The square in the corner. You see that square in the corner, you know it's a 90-degree angle. What other kind of angles do we know? Claire? An acute angle. Let me spell it correctly. What do we know about acute angles, Claire? Less than 90 degrees. So they're cute and little. So it's those little angles that are really cute and little. So I always remember the difference between acute and obtuse because the acute is nice and little. There is another angle. A straight angle. What do we know about straight angles, Harper? What do we know about degrees? They're exactly 180 degrees. Because if we look at that right angle, we can see it goes straight up and down. It's perpendicular with that bottom line. So a straight angle is actually two right angles. So 90 degrees plus 90 degrees is that 180 degrees. We are going to learn, we're going to review complementary and supplementary angles. Do you guys know those words? So we are going to be getting to those. I'm not going to focus hard on them right now because we will have objectives on them. But complementary angles are two angles that equal 90 degrees. So it could be 30 degrees and 60 degrees would be complementary because we can add them together. 45 and 45, 25 and 65. Two angles that if we add them together, they equal 90 degrees. They don't have to be adjacent. Adjacent means they share this line. They could be separated out, and we just know that that 30 plus 60 equals 90 degrees, so they are complementary. Sometimes they actually are adjacent. They share a side. So complementary angles equal 90 degrees. Any guess what supplementary angles equal? Robbie? 180 degrees. So complementary equals 90 degrees. supplementary angles, when we add them together, equal 180 degrees. So sometimes you'll see them on a line, sometimes they'll be separated, but if your two angles equal 180 degrees, they are supplementary. We will learn about vertical and corresponding angles later on. We don't need to focus on those right now. Right now, we're going to learn something new. So complementary and supplementary, we will have an objective on them, but it's not going to be till the end of the year. So I just wanted to give us a quick understanding of what they are. We have those angles can go together into triangles. How many sides does a triangle have? 3. Tri means 3. Triangles have 3 angles, 3 sides. So we are going to be learning about all different types of triangles because they can come in different sizes, right? They can look different. We can have triangles that look like this, or maybe we have an obtuse angle in our triangle, right? So triangles can look differently. Today, we're going to talk about triangles, and guess what kind of triangle that would be called? David?
A right triangle.
A right triangle, because it has a right angle. Okay, so right triangles have that right angle. We will learn about other triangles, but this right angle triangle has something really fun that we can do with it. Way back when, a long time ago, there was a gentleman named Pythagoras, and he developed the Pythagorean theorem. Now, we use the Pythagorean theorem when we want to find a missing side of a right triangle. It has to be a right triangle. So we're going to learn about different vocab words we use, and we're going to learn how that Pythagorean theorem works. So, for the right triangle, they have 2 legs. The leg are the 2 sides that make up our right angle. So we have one side here and one side here. Those are the 2 legs. The legs are always going to be A and B. So our legs of our right triangle are A and B. Directly across from that right angle, what letter do you think it is? C. And C's name is called the hypotenuse. So our right triangle is made up of 2 legs and 1 hypotenuse. The 2 legs are A and B. The hypotenuse is C. Now comes the Pythagorean theorem part. Alex? Anybody know what it is? Hadley? A squared plus B squared equals C squared. So we take our 2 legs, we square the A, and we square the B, and we add them together, and that equals our C squared. Let's see how this looks when we're working on finding a missing side. So before we find the missing side, we're going to see how the Pythagorean theorem truly works. So let's say we have this triangle. I know it's a right triangle because it's got the little square in the corner. Let's say we have 3, 4, and 5. So our 2 legs are what numbers? What's our A and our B? Kamala? Yeah. Our legs are those two sides that make up the right angle. So for a squared, I would do 3 squared. B squared would be 4 squared. And that equals the hypotenuse. That hypotenuse is directly across from the right angle. So that would be 5 squared. What is 3 squared? Robbie. What is 4 squared? Robbie. And what is 5 squared, Robbie? So, 9 plus 16 is 25. That truly does equal 25. Okay, this is just showing you that the Pythagorean theorem really truly works. All right, a squared plus b squared will always equal c squared. But how do we use that to find a missing side? This one, we knew all 3 sides. What if we need to find a missing side? So, let's see. Yeah?
What happens if one of the legs is bigger than the hypotenuse? On the side.
Let me give you some examples, and we'll see if we can answer that question. Okay. So you're thinking something like that? Yeah. So if this is, let's say this is 10. And this is, I'm trying to think of ones that'll work out evenly for me. I can't think of ones that are gonna work out. Oh, let's do this. Let's call this 15. And we'll call this one 8. Doesn't quite look proportionate, but let's call that 8. How would we solve this? Because we want to know our missing side. How would I set up my equation? What do you think, Harper?
15 squared plus 8 squared equals C squared.
Because we know our 2 legs are our 2 numbers that go here. So what is 15 squared? Eleanor?
15 squared.
So get use calculators. Luke?
225.
225. What is 8 squared, Beckett?
64.
64. That equals c squared. What is 225 plus 64? 289 equals c squared. So what is c? Christina? It's not, because that's c squared. So how do I get it to be just c? Christina? It's not 289 divided by 2, because when we square, it's not 15 times 2, it's 15 times 15. What's the opposite of squaring, Hadley? The square root. So do you guys remember how we find the square root on our calculator? Let me switch this over. To find the square root, remember we do the second button, then we find that square root that's on the calculator. It's underneath the x squared because they're opposites. So go to that x squared button, you do the second, then x squared, and you see our square root symbol. Then we put in our number that we want the square root of, 289. It's a perfect square. So when I click my button, I get 17. So you do the second button and the x squared, because we want the opposite of it, we want the square root. You put in your number that you want the square root of, 289. You hit equals, and if it is a perfect square, 17 times 17 equals 289, you get a whole number. Can we find the square root of a number that's not a perfect square? Yeah, we're just going to have decimals. Okay, so sometimes there'll be decimals, sometimes it'll be a whole number if it's a perfect square. Then it'll be a whole number square root. Okay, so let's go back. So that square root of 289, we find the square root of c squared. Square root of anything squared is it by itself, so that's c. What was the square root of 289, Hadley? 17. 17 is bigger than 15. Like it really wanted to know what if that leg is longer than the hypotenuse. Do you think that would ever be possible? It's actually not possible for a leg to be longer than the hypotenuse. If we have super tall and really little here, because we want this tall, this slanted line, it's still going to be a little bit longer because it's slanted. It will be longer. So that hypotenuse, I don't believe, could be shorter than a leg. Just by the nature of how triangles are. I don't think that would ever be the case with right angles. Okay. So the Pythagorean theorem only works with right angles. So now we have an idea of how we use it when we know both legs. Right? We fill in the a squared, we fill in the b squared, we add them together, we find the square root, and we're left with the hypotenuse, with that c. Sometimes we're given, let's say we have 40, and we have 9, and we have our question mark. How would I find that missing side? What do you think, Luke?
Would you subtract the square root of the a from the c?
You are so on the right track. Tell me how I would set that equation up. So looking at our equation, a squared plus b squared equals c squared, what do I fill in?
40. Well, yeah, 40.
So let's start with a squared. What would I put in for the a?
9.
9. So that would be 9 squared, because we know 9 is a side of that right angle, so it's one of my legs. Now what would I put?
Question mark? Oh. Minus. Times. No.
What operation is that, Luke? Plus. Do I know my b?
No.
No. So b squared is what I want to find. What does that equal?
C squared.
And what is my c squared? 40 squared. So I'm filling in the parts that I do know, right? I know my a and I know my c, so I fill that in. I'm trying to find the b. So the first thing I do is fill in what I know. Second thing is I do my squaring. What's 9 squared? Eleanor?
81.
So I've got 81 plus b squared equals what? What's 40 squared? Hadley?
59.
Now comes to what Luke had jumped ahead to, but I wanted us to see the steps. What am I going to do, Luke?
You subtract 81 from 1,600.
Yeah, because we want to get b by itself. So we have to do that opposite operations that we learned about a while ago. So we're gonna, this is a positive 81, so we need to subtract 81 from both sides. So my 81s cancel out, and I have b squared equals what's 1600 minus 81? Robbie? Am I done? Is my missing leg 1519? Why are you shaking your head, Robbie?
Because you have to find out the square root.
Oh, because we've got a square here that we need to get rid of. So what's the opposite of squaring? The square root. So we need to find the square root of both sides, because remember, whatever we do to one side, we do to the other side. We want to get rid of that square there, so we're left with just b. What is the square root of 1519, Natalie?
38.97.
Like I said, sometimes we have whole numbers, sometimes we don't. Robbie?
Wait, you don't know round down there, or you just keep it?
Usually you round to the 100th place. So if it goes to the 100th place, you stop there. If it goes farther, you would round to the 100th place. Okay. Does that make sense, how we find those missing sides? If it's the hypotenuse, that c that's missing, it's easy. We just have to add the a and the b squares together and find its square root. But if it's a leg that's missing, doesn't matter which leg, you can call one of them A, one of them B, it doesn't matter which one, because we're just adding them together. And then you subtract it from the C by the square root, because we want to get that B by itself. Sometimes it'll be a decimal because it's not perfect square. I made this problem up, so it's not a perfect square because I was going quick. So sometimes you'll have decimals if it's not the perfect square. Make sense? Any questions about the Pythagorean theorem? So this is something that you will use, especially in geometry. You will use this, you will see this again. So I'm just giving us a brief introduction. Math 6 had just one objective, brief introduction into it, but I wanted you to at least know about it, so when you come to it again, you're aware of what it is. So we're not doing a full-on objective about it. We have an idea of how it works, remembering that squares have the opposite of a square root. So when we're talking about PEMDAS and we say parentheses, then exponents and radicals, exponents would be that squaring, radicals would be the square root. They are the opposites, just like multiplying and dividing are opposites, adding and subtracting are opposites. So it's important to remember that squaring is the opposite of the square root. Now we're going to look just a little bit at some graphs. Math 6 is going to be doing this their next unit. I'm going to give us just a little bit of an idea about square. Well, first I should ask, is there anything about angles and triangles and stuff that we have questions about? Okay. So, we know what it means to do mean, median, and mode, right? We've been working with mean, median, and mode in our math packets. How do we find the mean of a data set? Christina? Yeah, if you add up all of your data, and if you had 5 numbers that you added together, you divide that total by 5. And that will tell you the mean. What is another word for mean? Eleanor? The average. So if you find the mean of a data set, it's the same as finding the average. Sometimes people use different vocab words, and you go, well, I have no idea what that means. What do they want me to do? It's just knowing that it means the same thing. So if you're finding the mean or the average of a bunch of numbers, it means you add them all up and divide that total by how many numbers it was that you added up. Another thing that we do with our data set is the median. What is the median, Natalie?
Like the middle number?
The median is the middle number. We need to arrange all of our numbers in order from least to greatest. You look to the middle. Can we ever have two numbers be our median? Well, I see some people saying yes, some people saying no.
Well, you can't have them both.
Harper?
So you can have two, but that would be even, but then you do
So technically, when we are putting down our median, you cannot have two numbers. Sometimes when we have an even set and we're canceling out our numbers, we end up with two in the middle. But then you're right, Harper, we have to find the average of those two numbers. Because we can only have one number for the median. So if we have two numbers, if we had 10 and 12 are in our middle of that data set, you add those two numbers up and you divide it by 2 because there are two numbers there. So our median would be 11. If you put 10 and 12, it would be wrong because you cannot have two numbers as a median. If you have an even number in your data set, it'll look like you have two numbers in the middle, but you have to do the math to make it just one number. You have to find the average of those two. What is the mode? Ruby.
the number that
The number that appears
appears the most.
the most. Mode is the most. Can we have more than one number be the mode?
Yeah.
What if I have a data set that looks like this? What would my mode be? Oops.
What, 2 and 5?
It would be 2 and 5 because they are both seen 3 times. Can we have multiple numbers be our mode? What if my data set looks like this? What is my mode? Natalie?
All of them? There is no more?
There is no mode. So if we have a data set like this, we would say no mode. Sometimes I have friends that say 0. 0 is a number. You cannot put 0. You would have to say no mode. How about the state? She is in Mrs. White's house. Yep. So, we can say no mode. We can have multiple modes. We can have one number for the mode. Okay. But you don't put a 0 if it's no mode. It's not 0 modes. It would be no mode. Or none. Something like that. We have one more data set word. Does anybody know what word that is? Robbie? The range. What is the range? Amala? When we put those numbers in order, so if we had 1, 2, 3, 5, 9, 10, that's my data set. I put them all in order, so if they're all jumbled up and mixed up, you have to put them in order, just like the median. You have to put them in order. Tell me what my range would be, Amala. How did you get that? You take the biggest number, you subtract the smallest number, and our range would be 9. So the range goes from the smallest data number to the biggest data number. How many is in between that? Doesn't matter how many numbers you have written in your data set. It's just going from the smallest to the biggest. What is their difference? So, doing data sets, we've done in our math packets, we've made graphs using bar graphs or line graphs. So we know how to do those, right? Our bar graphs, we have our words on the bottom, always have to label, tell me what those words mean. Going up the side, we'll have numbers, tell me what those numbers mean. Bar graphs, we have different bars measuring out the number of how many things there were, right? We know how to read bar graphs. Thumbs up if you feel comfortable with bar graphs. A line graph is the same thing, except instead of bars, we have our points that get connected. Thumbs up if you feel good about bar graphs. There are more graphs that we have not been exposed to yet. So there are, we call them, let's see, stem and leaf plots. Yep, I have it on my board over there. There are box and whisker plots. Again, on my board over there. Those are new types of graphs that we haven't learned yet, but we will see. There are circle graphs. How do we read a circle graph? So the next time we do a Math 6 review, we're going to review some of those graphs that we haven't learned yet. Bar graphs and line graphs, I know you're comfortable with, but I want you to understand some of these other graphs that we're not going to do objectives on in pre-algebra. Math 6 is going to be learning about them. I want you to be aware of those also, okay, because we skipped over them. So just know the next time we do a review, we're going to learn some of those graphs on my board that we haven't seen before. We're going to get an idea of what they all mean. So again, this is not homework. This isn't something I am testing you on. This is something I'm trying to catch you up on because we hadn't learned Pythagorean theorem. We haven't learned about these graphs. So if you're listening to this at home, this was just a, hey, let's take some notes. If you wrote those notes on a loose leaf paper, you can actually put them in your math binder at the back end so you don't lose it. You can put it in your file folder. Okay, it was just good information for us to have. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.